In today's video, we're going to talk about section 5-2, substitution. And we know what substitution is. It is just replacing one with another. We've talked about that in the past, but we're actually going to be talking about substitution when dealing with systems of equations. So we're going to be looking at systems of equations that we did in the last video with graphing, but now we're going to be using an algebraic method called substitution. So first we got to ask ourselves, who likes graphing? And usually we say, no, I hate graphing. It happens. A lot of people don't like it. But the big question is, why not? Why don't we like graphing? Okay, that's the big question. A lot of people can't answer is because, well, it can be hard, messy, inaccurate. So if we get rid of these, if we move over past the graphing approach, we find that we can get a more exact answer, because what if our answer isn't a whole number like it has been in the past? What if it becomes a fraction? What do? We're not going to, it's unlikely we're going to guess an answer of 7/8 and 15/30 seconds. It's just, no, we might, 1/2 and 1. That's what we're going to be looking at. So we got to remember that fractions and decimals are still out there. Using algebraic methods will help us develop those answers. So let's use substitution to solve each system of equations. So we always want to solve for one variable. It doesn't matter which variable, but I always say look for the easiest one to solve for. So in the first one, A, and I'm going to move this if I can, so I have more room to work with here. So I have y equals 3x and x plus 2y is equal to -21. So I see right away that one variable is already solved for. Y is already solved for by itself, and it tells us y is 3x. So what we want to do is take that 3x and plug it into the other equation where y already is. Okay, so now my new equation becomes x plus 2 times 3x, exactly. So I took y out and I'm putting y in, or 3x in, because they're the same, is equal to -21. And so now all I have to do is simple algebra. So I have x plus 6x multiplying is equal to -21. X plus 6x is 7x is equal to -21. Divide by 7 on both sides. So I get x is equal to -3. And now I take that and I plug it into one of the two equations that I have up top. It doesn't matter which one. I'm going to go to the one that's going to be the easiest. I'm going to put it right back where it is. And I end up with y equals 3 times -3, which gives me -9. So now my final ordered pair answer would be -3, -9. So now I have a method to solve for x, or our coordinates, without having to graph. Now, the next one, x plus 5y is equal to -3, and 3x minus 2y is equal to 8. So as I said before, always find the one that's easiest to solve for. I noticed the first one, that one has the easiest one to solve for. So if I just go, I'm going to take it over to the side, x plus 5y is equal to -3. All I have to do is just subtract 5y from both sides, and that tells me that x is equal to -5y minus 3. So all I had to do was just move something. That's really easy. So now I'm going to take, since I have my x isolated, I'm going to take that -5y minus 3 and I'm going to plug it into the other equation where x is. So then I get 3 times, hopefully I don't run out of room here, 5y minus 3 minus 2y is equal to 8. And so from here, I'm just going to do some simple arithmetic, some algebra. So I'm going to distribute. So I get -15y plus, sorry, not plus, that's a typo, -9 minus 2y is equal to 8. Combine like terms, I get -17y is equal to Forgot my 9. Sorry about that. Negative 17y minus 9 is equal to 8. Add 9 to both sides. I get negative 17y is equal to 17. Oh man, this one's working out nicely. Divide by negative 17. So y is equal to negative 1. From there, I'm going to take that 1 and plug it into my equation I already solved for. So I have, I'll scroll down just a little bit more, x equals negative 5 times negative 1 minus 3. So I get x equals 5 minus 3, so x is equal to 2. So my final answer is 2 comma negative 1. And there we go. Okay, it can be a long process. Sometimes it's very quick and simple. Sometimes it's a little bit longer, but it's fairly step by step. All right, next one, use substitution. We're just going to do a couple more examples. So I got one already set up for us. It's kind of nice. So I see right here, that one's already solved for us, so I'm going to plug that in right there. So 2x minus, and put it in parentheses, 2x minus 3 is equal to 8. So distribute that negative. So I get 2x minus 2x plus 3 is equal to 8. Well, the 2x and the 2x cancel, so I'm just left with 3 equals 8. Well, wait a minute, that doesn't make any sense. 3 doesn't equal 8. Okay, so when you ever have a situation like this where variables go away, okay, and you're left with just numbers, and if you get a false statement like this, like 3 does not equal 8, that is false. Okay, false statements equal no solution. All right, so false means no solution. And if you're thinking, you can kind of guess where the next one's going, but we're still going to go through it. All right, so the next one, neither of them are really good to work with, so I'm just going to start at the front. I'm going to do the bottom one. So I'm going to add 8x to both sides. And so I get 6y is equal to 8x minus 2. I'm going to divide everything by 6. So I get y is equal to 4 over 3x minus 1/3. Now I know we got fractions, and fractions are scary, but it's okay, we'll live. Okay, so I'm going to take that, and I'm going to plug it into the other equation where y is. So I'll plug it in right there. So I get 4x minus 3 times, now put in parentheses, 4/3 x minus 1/3 is equal to 1. Okay, so let's distribute. Remember, I'm distributing a negative 3 here, so I end up getting 4x minus, now negative 3 times 4/3, the 3's would cancel out, so I'm left with 4x. And negative 3 times negative 1/3 is just positive 1 plus 1 is equal to 1. Once again, I have my variables cancel out, so I'm left with 1 equals 1. Well, in this case, we have a true statement. Our variables went away, and 1 is equal to 1. That is true. So if we have a true statement, that means we have infinite solutions. And I'm going to run a room, so I'm just going to abbreviate solutions as SOL. Infinite solutions. Okay, so true means infinite. So